let me just finish up this last bit of comments, which I was just about to do when the phone rang. Here we go. Advance one frame. Not I. Interesting. One frame. Compare total number of frames and pretty much if not finished, loop. There, that runs you back to the main game loop. There we go. I'm just going to save that file now, and I want to grab all of this, Control A, copy, and so there is another type of timer that's built in to the hardware that I could have used instead of doing this nested loop, it's called, to burn time. So I'm going to do that now just for demonstration purposes. Add a new file. This is called Jiffy Clock. There we are, Jiffy Clock. Paste the old code. Let me put clear screen right on the very beginning of the loop. Okay, so all of this timer, nested loop timer that I made is going to get replaced now using another method. Let me go, oops, semicolon, Jiffy Clock or Jiffy Timer, either way, whatever. Okay. First thing I'm going to do, let's store a value, load a value, LDA number 255, and then we'll store that in the built-in Jiffy timer 162, memory location 162. Okay, now I want to burn that up a little, so I'm going to have a little mini loop here. I'll just call it Jiffy, and then let's load that Jiffy timer value, and it's burning one of this value each time. So let's loop back using branch minus back to here. There, branch back to Jiffy. See what we got. Okay, built in. So that's nice. Handy. Let me adjust the timing a little here. So just for reference here, let me just grab this bit of comments here. Copy that down here. There. The way the Jiffy Clock works, it is a built-in bit of hardware residing at memory location 162. The Jiffy Clock uses 1/60th of a second. I'm assuming that means it uses 1/50 of a second for European models. I could be wrong on that. This is tied to a clock, an actual kind of clock that keeps track of actual time. So in the previous tutorial, I burned ticks in assembly, you know, and if I were to add more code, then I would have to adjust the timing value. But the Jiffy clock is tied to an actual internal clock, you know. So even if you change the amount of code around, the duration should remain the same. Okay, so 162 incremented by 1 every 60th of a second, every jiffy, right? And then it rolls into 161 every 256 jiffies. So if you wanted even slower ticks of jiffy time, you could use value number 161. And then 161 rolls into 160 every 65,536 jiffies. So if you want to just excruciatingly slow, so slow you wouldn't see anything happening, then you could use the 161 value. Okay, I'm sorry, 160 value, and it would run super slow. Okay, so 186, 60 jiffies, it's a 60th of a second, so 60 jiffies equals 1 second. So if I were to put 186 here, I should get a jiffy duration of approximately 1 second. 1001, 1002, 1003, 1004. You see? So there, you can tweak this value for different timing now in your animation. And that's just another way to do timing. I could have done Jiffy first instead of doing the nested loop. The nested loop, of course, is super faster than using the Jiffy. Maximum value here, of course, is 255. Right, so you can use from 128 to 255. I think like if I went 126 here, then it doesn't seem to work the same. Don't quote me on that. There, I get nothing at all. So I'm not quite sure what's up with that. Yeah, but a minimum of 127. Let me put 127 there. Play around. Nope, 128. Let's try that. Uh-huh. And it's running very, very slowly, you see. So let me uh, set Jiffy Clock. We'll say 128 to 255. There you go. Store in Jiffy timer. Call. Oops. Call Jiffy. Good enough. And then loop timer there. So that's just another way to do timing in your animation. As you can see, it has some limitations. If you wanted it to go, your animation to go much faster than the maximum value of 255, then you would use the other method that I showed you, using nested loops to burn time and make your adjustments accordingly. There you go. That is the Jiffy Clock.